everyone, welcome back to our build. This week I'm going to be going over our electrical system, starting with the major components of the system, which I consider to be the battery, the charge controller or charge controllers, your charge sources, and your inverter. So for all of these things we went with Renogy, and that was really for two reasons. One was just the convenience and simplicity to buy everything in one place. There are other companies which I think have similar value to Renogy, but they will only make batteries or only make solar panels. So it was nice to be able to get everything I needed in one purchase. The battery we have is a 200 amp hour lithium iron phosphate battery with Bluetooth. The reason I picked this battery is because I knew I wanted 200 amp hours just based on the estimates of what I think we'll use. And then from there, it was just cost. So Renogy doesn't have a 200 amp hour battery without Bluetooth, and buying two of their non-Bluetooth 100 amp hour batteries would have been more expensive. So we landed on this one. So just about the Bluetooth of the battery, that is just a battery monitor. So it lets me see the battery voltage, incoming current, outgoing current, all that stuff from my phone. If your battery does not have a built-in battery monitor, that is something you want to get separately so you can at least see the voltage of your battery, because the voltage is directly tied to the state of charge of the battery. For example, our battery, which is 12 volt lithium iron phosphate, at 100% state of charge, it will actually have 13.6 volts across it, and at 0% state of charge, it will have 10 volts. So at least being able to see the voltage of your battery will cue you into how charged the battery is. They make standalone battery monitors, whereas that's all that component does is monitor your battery. Also, there are some charge controllers which will have built-in battery monitoring, so you can monitor your battery through your charge controller. Now on to charge controllers, we got the Renogy DCC30S charge controller, and I picked this charge controller because it is two charge controllers in one. So this will take care of both solar charging and DC to DC charging. For me, this is an ideal setup for an RV or van system. Not only is it cheaper than buying two different charge controllers, but it's also smaller. You require less of a footprint to mount one charge controller instead of two, and then it simplifies all of your wiring because you have to wire one charge controller instead of two. The downside to this type of controller is it has a pretty significantly lower max solar input voltage. The charger we got has a max solar voltage of 25 volts. A similar controller that is dedicated to solar will have a max input voltage of 100 volts. Based on what I knew our solar setup would be, this max voltage wasn't going to be a problem. And I think in generals on like a van or RV, the solar systems are smaller, so that helps to keep the voltage down. As well as from what I've seen online, RV systems are typically connected in parallel, which keeps the voltage down. Moving on to solar then, we have two 100 watt 12 volt compact design panels, again from Renogy, and I have them connected in parallel. Next to the panels in parallel rather than series, because parallel gives better charging in mixed conditions. Solar panels connected in series will give you a higher charging output if all the panels are in full sun. If some of the panels are in shade and some are in sun, all of the panels get reduced to the performance of the ones in shade. Essentially, when solar panels are in series, they all act as one system and only perform at the lowest performing panel. However, when panels are connected in parallel, they act independently of each other. So if one panel is in shade and one panel is in sun, the panel that is in sun is not restricted at all by the panel that's in shade. The downside to connecting in parallel is if you do have full sun, you'll have a lower charging output than in series. But on a van and the sun shade situation is going to be unknown and always changing, I decided to go with the connection that's going to give me the best results in variable conditions. Also, the max voltage for a series connected system will be the max voltage of each panel added together. So for example, our system having two panels, the max voltage of each panel is 20.4 volts. So if the panels were connected in series, I would have a max system voltage of 40.8 volts, which is above the 25 volts that our charge controller can handle from a solar system. So with our charge controller, we wouldn't even be able to see the benefits of a series connection if we wanted to do that. So the last major component of our system is our inverter. We got a 2000 watt pure sine wave inverter, and I apologize if it annoys anyone that it's mounted upside down, but it just worked better for our wiring to have the inputs on the left and the outputs on the right. So I got the 2000 watt inverter purely because we use our Vitamix and Instant Pot quite a bit, both of which have an 1800 watt draw. So you'll just want to base the size of your inverter on the appliances that you use. thing that you do want to be sure of is that it is a pure sine wave inverter. If not, you can damage your AC appliances if you try and power them with it. Now with the major components covered, I'll go into how everything is connected. Starting with the battery, I used 2-aught cables to connect the battery to the system. The negative terminal is just connected directly to the negative bus bar. For the positive battery terminal, it first goes through a terminal fuse, and this is really like an oh shit fuse. If this fuse ever blows, multiple other things have failed further down the line in the system, so it's kind of a last hope in saving a catastrophic failure. From the fuse, it then goes to a system switch, and that is how I can disconnect and connect the battery to the system. This switch, along with the 2 charging source switches, will allow me to completely cut off electricity from everywhere in the van. So if I ever need to do any work and I'm not sure if there's power to it, I can just turn all the switches off and know that there's no power anywhere in the van. Then from the system switch, it goes and connects to the positive bus bar. Then we'll look at how the inverter is connected. So I also used the 2-aught cables to connect the inverter. Now this is a bit of overkill for the inverter connection, but just because of the minimum amount of 2-aught cable that I had to purchase, I had enough left over to also connect the inverter with it, so I did. So the negative connection, again, is pretty straightforward. It goes directly from the negative bus bar to the negative terminal on the inverter. Then the positive connection first goes through a fuse, and then from the fuse it goes to the positive connection of the inverter. And then the only other outputs from the bus bars are to our DC fuse hubs. We have 2 DC fuse hubs, one on the passenger side and one on the driver's side, and I have them wired in separately. The negative connections just go directly from the negative bus bar to the negative terminal on DC fuse boxes, which for these is on the top. Positive connections go from the positive bus bar through a fuse, one for each fuse box, and then to the positive terminal on the fuse boxes, which is on the bottom. Looking at how the fuse boxes are wired, we have all the negative connections on top, and those go directly from each device to the negative terminal. All of the positive connections have an associated fuse with it. So you can see I have a lot of things wired into this fuse box, but very few fuses in there, and that's because there's actually only a couple things connected, like the heater and the fan. Lastly, we'll go over the incoming power for our system. So again, we have 2 sources of charging, being DC to DC and solar. The negatives from each of those sources go directly from the source to the negative bus bar. Positive wires from those sources first go through a fuse and then through a switch. You can see for DC to DC, it goes through this fuse, then this switch, and up to the controller. And for solar, it goes through this fuse, then this switch, and up to the controller. Taking a quick look at how the controller is wired in, here we have the solar input, and here is the DC to DC input. Each input is labeled on the controller, and Renergy has a really good video going over how to connect this controller on their website. This wire is the ground for the charge controller, and this goes directly to the negative fuse block. And lastly, we have the output power, and this wire goes directly to the positive fuse block. So you can fuse this wire as well, but because I have both of the incoming charge sources fused, I decided I didn't need a fuse. The last wire that's coming out here goes up to a Bluetooth module, which allows me to see all that's happening with the charge controller from my phone. That's going to be it for this week's video, everyone. I hope this information was helpful, and we'll see you next week.